Brian is lead scientist and will demonstrate high frequency on 5G modules using LTCC. Very good. It was right in front of me. Brian, the stage is yours. Everything looks great.
All right. Thank you very much. I appreciate the invitation to come talk about our materials. So first, I want to go into an introduction of motivation in 5G. So in response to society's increasing appetite for more and more data, telecommunication networks are looking to increase wireless communication bandwidth and connectivity. And a critical aspect of this is the hardware, the devices that will need to operate at higher frequencies, at frequencies known as mmWave, or about 20 gigahertz. Unfortunately, current device designs use materials that will not deliver the efficiency in terms of power utilization or with practical economics. But if you could integrate the semiconductor chips in the same modules as the passives and the switches and the filters and the antenna structures, this will shorten wiring distances and increase electrical efficiency, as well as miniaturizing devices, which are all good things. Using materials that not only allow for increased integration, but also have stable performance at high frequency and at a myriad of operating conditions are critical to realize the advanced designs at these higher frequencies that will give us more data. But they also will provide hardware that will give a robust build out and avoid things like field failures or unnecessary maintenance costs in the field. And so that's why we focused on 5G. And so what I really am here to talk about today is our product line called DuPont GreenTape LTCC. And if you're not familiar with this technology, we tape cast a ceramic slurry of precursor particles. It's a flexible tape that can have vias punched in it, filled with metal paste, have advanced screen printing of XY traces of conductors, and then layers stacked, laminated, and co-fired at what's a relatively low temperature for ceramic processing. And what results from that, I put on a chart here in the middle, a traditional printed circuit board that's ubiquitous around the electronics industry. Our ceramic LTCC is a similar 3D layered construction of a circuit, where here now, instead of the dielectric being something like FR4, which is pre-break filled epoxy or plated copper, we have a very high quality dense ceramic material with metallization paste created conductor lines. In this case, I'm going to talk about silver today. And so this takes advantage of all the great material properties of ceramic, but in the same laminar kind of construction to make very complex circuits. And like PCB, you can make chip packages, components, all kinds of things. So LTCC is a relatively mature technology. It's been around for decades. It's been used for antennas and components and even antennas, but you can use it as a chip package. To date, it has somewhat fallen out of favor and has a current perception, and I would say a misperception, that it's fundamentally hard to prototype or expensive or a costly process. PCB is ubiquitous. LTCC is a little bit lower installed base, and so I think that's just a transient state of the technology. But really what justifies the use in revisiting this material is the great material properties. So I show here one of our systems. The loss tangent on the left here is the lowest for any LTCC commercially available material in the millimeter wave frequency regime. And you can see over a wide range of frequencies, the loss stays very low. The dielectric constant is stable. But not only is it a good dielectric material, it's stable under a host of conditions. So under a wide temperature regime, the loss and dielectric constant don't shift. It's impervious to moisture or hermetic, and so there's no fear like there is in FR4 printed circuit board materials that humidity will drift dielectric properties and change device design. And in addition, the thermal properties are superior to any organic solution. So an order of magnitude higher thermal conductivity, CTE that's matched to the semiconductor devices, and a strong flexural strength. So ceramics are fragile, but these ceramics are tough, and so they're strong, rigid substrates. And material properties are not the end deciding factor in how to make an electronics device, and we recognize that. So we've partnered with a research institute in Taiwan, ITRI, and made what I show here is a module. The basis is LTCC, and so this is a multi-layer package with antennas on one side and the ability to assemble all the chips and passives on the other side. I show a picture of it fully assembled and a schematic of what it looks like in cross-section. This was put into a system that's represented by this block diagram where all the LTCC is the emitter. We can characterize all kinds of antenna properties of this phasor array, beam steering, beam-formed system. But the real proof here is that we can build a system that transmits 4K video up to 10 meters across a conference room. And this was a relatively simple design that was quickly prototyped and really had no hiccups in thermal design, which is unusual for a high power, high frequency device with multiple antennas. And so we think this kind of reference design kind of proves the point that LTCC is a superior material and easier to design. And so in conclusion, I think LTCC has a lot of myths associated with it, but if you think of it from a total solution standpoint, these great material properties that we're quite proud of can be utilized in a design when you think about the total cost of the whole solution. And although there may be some differences in the value chain and the prices, I think if you think of the total solution, it justifies what's already occurring increased manufacturing base. And so we'd like to talk to whoever would be interested and work with them to try and make designs to sort of unlock the power of these materials in current designs. Thank you.
Well done, Brian. Impressive work. I've seen thumbs up and applause coming up the whole time during the presentation. So people liked your talk, and that this went smoothly is really great.